Today's objective is to use the quadratic formula. We'll review a little bit. We will find the quadratic formula, where it came from, and we will use it to solve equations. Deriving the quadratic formula. So here, the opening exercises are review from what we did before. Here is x plus 2, or not x plus 2, but x squared plus 2x equals 8. If you're going to solve this by completing the square, there is no need to move anything. That 8, if you move it to the left, it's going to have to go back to the right eventually. So let's just leave it where it's at. And we'll start by finding half of 2. Half of 2 is 1. If you square the 1, you get 1. So we're adding 1 to the left side. What you do to one side, you must do to the other side. And then write it in the proper form. X plus, and then the sign in front of the middle term, plus, and then half of 2, 1, close the quantity and square it. And then 8 plus 1 is 9. To undo that perfect square, you have to find the square root. What you do to that side, you do to this side. You're left with x plus 1 equals plus or minus 3. You have two things to do now. You have to do x plus 1 equals 3 and x plus 1 equals negative 3. On the left-hand side, that's 3 minus 1, which is 2. And on this side, it is negative 3 minus 1, which is a negative 4. So your answers are x equals 2 or x equals negative 4. We have to solve this one by completing the square. You have that plus 4 there on the end. You can move it to the other side. And I'll leave myself some room here. You can make that negative 4 on the right side. But over here on the left, you're left with 7p squared minus 12p. Remember, to get the p squared by itself, you have to take out the 7. And you're left with p squared. You're dividing 7p squared by 7. If I divide minus 12p by 7, I get minus 12 over 7p. Now we have to find half of 12 over 7. Half of 12 over 7 is just 6 over 7. And then we square the 6 over 7. When we do that, we're adding 6 over 7 squared here. And what you add to one side, you have to add to the other. But we didn't really add just 6 over 7 squared. What did we add? We have this, but what about this out here? You do what with it? You multiply it. So we've really added 7 times 6 over 7 squared. So that's what we're going to do on the other side. We're going to add 6 over 7 squared, or 7 times 6 over 7 squared. So just to review that, we moved this 4 over to this side, made it minus. We found the factorization. We took the 7 off the p squared, put 7 out here. Divide each of these by that 7 to get these two terms. Half of 12 over 7 is 6 over 7, but you have to square it. We really added to the left side 7 times the square of 6 over 7. So that's what we must add to the right side of the equation as well. So what we do from this point is we have to simplify this stuff. Alright, so over here on the left-hand side, we want to put this in the proper form. So we're going to have 7 times the quantity squared of p, the sign from the middle, minus, half of 12 over 7, which is 6 over 7. Close it off, square the quantity. And then on the right-hand side, we have this stuff over here to simplify. So we have a negative 4 plus 7 times the quantity squared of 6 over 7, which is 36 over 49. And we can simplify that a little bit more. So let's go over there and cancel what we can. We have 7 into itself once, into 49 7 times. So we're left with plus 36 over 7. And we can still simplify that some more, just keeping the left the same. If I have a common denominator, if I made this common denominator 7, then I would have to multiply this top by a 7. So I would really come out with a negative 28 over 7 and then plus 36 over 7. So again, we keep the left-hand side the same. Negative 28 plus 36 is just 8. So we end up with that. We have to divide the left-hand side by 7, and what we do to the left-hand side, we got to do to the right. We have to get rid of this 7. So when we divide the left-hand side by 7, this is what we're left with. If I divide the right-hand side by 7, multiplying by 7 is the same, or dividing by 7 is the same as multiplying by 1 over 7. So if I multiplied this over here by 1 over 7, I'd be left with 8 over 49. And now we have to get rid of the perfect square. So that means we have to do the square root of both sides. So we end up with p minus 6 over 7 equals plus or minus the square root of 8 over 49. Now you can write that like this. 8 is not a perfect square, so you can keep the square root symbol on top, but on the bottom 49 is a perfect square. Its square root is just 7. So what we end up with is this. We end up with p equals plus or minus the square root of 8 and then over 7 plus 6 over 7 when we move this over. And you could do that twice, once with a positive, once with a negative fraction here. But since this doesn't come out to be a perfect square, it would end up being a decimal. We'll just leave it in this form here. This is the general form of a quadratic equation. This should look familiar. You have ax squared plus bx plus c. And what we're going to do with this general form is we're going to solve this general form by completing the square and see what we come up with. And see if it looks familiar after we do all of that. Alright, so if I were going to solve this by completing the square, what would be the first thing that I would do? Yeah, you could move that a to the outside of this grouping here. So you could come, and I'm going to use capital letters. I don't like writing lowercase letters. So I'll have an a on the outside. That means that leaves me with x squared, and then what? What do I have to do to bx? Plus bx, and over what then? Over what? A, yeah, we have to divide this by the a that we factored out. So plus b over a. and then that would be an x beside it. Okay, what do we have to do to find out what we have to square and then add to both sides? What do I do to that middle term? Divide by 2. If I divide b over a by 2, what do I get? Dividing by 2 is the same as multiplying by 1/2. So what happens when I multiply b over a by 1/2? When I divide b over a by 2, I get b over 2a, but I have to square b over 2a. And I come up with the square of b over 2a. Like that. But what I do to one side, I have to do to the other. So here's the equal sign. What about that c? Where can I put that c? Right-hand side, and it becomes minus c. Remember, we just added this, but it's really this times this, like we did in the review problem. So we'll go over to the right and add the same thing. A times the quantity squared of b over 2a. So we've balanced the whole thing out. Here's a. We need the variable x, the sign from the middle, plus, and remember, half of the middle term was b over 2a. So we have b over 2a. That should be a 2. b over 2a, and then quantity squared. And on the right-hand side, you can simplify that. You have your negative c, and then you have a times, you have b squared, and then over the quantity squared of 2a. You have to distribute this exponent to each of these, so you would end up with b squared over 4a squared. And we can simplify that even further. We'll keep this side just like we did on the opening exercise. We'll keep this side the same, and we'll simplify here. You have an a there that goes into itself once, and down here you have an a squared. A will cancel out with that a squared and just leave you with an a on the bottom. So you have negative c plus b squared over 4a. We want to get rid of this a here, so we're going to divide the left-hand side by a, being left with that. Over here, if I divide by a, I have to divide each piece in there by a. So I would end up with negative c over a, and then b squared over, remember what happens when I divide by something? It's the same as multiplying by 1 over that something. So I would be multiplying technically up here by 1 over a. That's the same as dividing by a. So I would have 4a squared on the bottom. So on the left-hand side, we're going to keep this the same. And on the right, we need to simplify this. We need a common denominator. We have 4a squared here, and we have just an a there. What would I have to multiply this a by in order to have a 4 and an a squared? What 4, I would multiply it by 4 what? Not 4 squared. I would have to multiply it by 4. But to get an a squared, what do you multiply a by to get an a squared? A. So I would need to multiply this by 4a. That would give me 4a squared. There's already an a here. I need to make the a squared, and I need to have a 4 in there. So technically what I'm doing is multiplying by 4a there, and up here I'm multiplying by 4a as well. So that would give me minus 4ac over 4a squared. And then I still have plus b squared over 4a squared. Alright, so now that we've done that, we can keep the left-hand side the same. And then over here we want to add these two fractions together. You have the same denominator here, so that's what we're going to have here, 4a squared. But on the top, why don't we make this one little adjustment? See how you have minus here, and then this is plus? Why don't we just write it as b squared minus 4ac? Like that. All we did is just reverse these two down here, just in a different order, so the minus sign is not first. Okay, all we have to do now is to find the square root of both sides. And when I do that, I'm left with this. X plus b over 2a equals plus or minus the square root of b squared minus 4ac over 4a squared. But I can simplify that. On the top, b squared minus 4ac is not a perfect square, but on the bottom, do we have any perfect squares on the bottom? Is 4 a perfect square? Yes. Is a squared a perfect square? Yes, it has a square sign on it, so it's a perfect square. So we can simplify that a little bit. Keep the left the same. And then on the right-hand side, we can have plus or minus the square root of b squared minus 4ac on the top, but on the bottom, we can just be left with the square root of 4, which is 2. And what's the square root of a squared? What? It's what? A. It's just a. Yeah. All right. So look what happens now. Let's move this to the other side. And you come up with negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Do those two fractions have the same denominator? Yep. So we can combine them together. Negative b plus or minus the square root of b squared minus 4ac over 2a. And this is called the quadratic formula. We just found the quadratic formula to be negative b plus or minus the square root of b squared minus 4ac. All of that over 2a. And with that formula, you are going to solve the problem of x squared minus 2x equals 12. You must have it in the proper form. ax squared plus bx plus c equals 0. What must I do to our problem in order to put it in that form? So we moved our 12 over to this side. From here over to there, changed the operation. And now we have to figure out what a is. What is the number to the left of x squared in our problem right here? It's written on the screen. 1, yes, so a is 1. Even though it's not written, there is really a 1 there. So b. Notice in the general form, the b is right beside the x. So what is our number for b? Negative 2, because it has the minus 2 in front of it. So we'll go negative 2. And then C. What is C? Negative 12. You have to insert A, B, and C into that quadratic formula as 1, negative 2, and negative 12. So when we put those in, we get negative 2, plus or minus the square root of the quantity squared of negative 2. Don't just put negative 2 squared, because you know that if you type in negative 2 and square it in your calculator, it's going to be negative 4. You have to include it with parentheses, and then minus 4 times 1 times negative 12. All of that over 2 times 1. We need to simplify it now, so we're going to have a double negative out here. Remember, that was negative b in the formula. But we already have a negative sign with that b, and the number was negative 2, so that's why we have a double negative, which is a positive 2 now. The quantity squared of negative 2 is 4, and then we have minus a negative. Minus a negative is plus. 4 times 1 times 12 is 48. On the bottom, 2 times 1 is just 2. Four plus 48 is 52. When you get to your final answer and the number under the square root sign is not a perfect square, 52 is not a perfect square, then you can leave your answer like that. Or you can write it as 2 plus square root of 52 over 2, or 2 minus the square root of 52 over 2. 1/2 r squared minus 6r equals 2. What do I need to do to this in order to get it into the proper form? Yeah, move the 2 to the left and make it minus 2. So we really come out with this: 1/2 r squared minus 6r minus 2 equals 0. What is A? A is a half. What is B? Negative 6. And what is C? Negative 2. Alright, so our formula is negative b plus or minus the square root of b squared minus 4ac over 2a. And we will insert those values into the formula. Now we have a negative 6 for b, and there's in the formula it's negative b, so you're going to end up with a double negative again. Negative 6 plus or minus the square root of the quantity squared of negative 6 minus 4 times a half times a negative 2, and then all of that over 2 times a half. A double negative 6, that's just going to give me 6, plus or minus. The quantity squared of negative 6 is 36. You have a minus 1 negative in there, so that means the sign goes to plus, makes it a double negative. And then 4 times a half is 2, 2 times 2 is 4. And on the bottom, 2 times a half is just 1. So if you simplify under the square root sign, you come up with a 40, and there's no need to put it over 1. It just drops out. Anything over 1 is itself. Alright, so we come up with 6 plus or minus the square root of 40. Now you can simplify this. If you leave it like this, I'd be okay with that, because we have to spend some time doing the following. Even though I would take this answer right now, in the future, Here's how you can break this up. Can you give me a perfect square that will divide evenly into 40? Which one? Oh, you can? I say there is. What are the perfect squares? What's the first perfect square? 1 squared is what? 1. So what's 2 squared? 4. Will 4 divide into 40 evenly? So how do I divide up 40 with a 4? 4 times what? 10. So I would have square root of 4 times square root of 10. What's the square root of 4? Square root of 4 is not 16. It's 2. Square root of 4 is 2. This is another way you could simplify the answer there, like that. For right now, I'll go ahead and take this.